Welcome to lecture 5 of MCS 472, Introduction to Industrial Mathematics and Computation. So what is the goal of this lecture? I will try to illustrate how you can get data, temperature data, meteorological data, how you can get data, actual data, and get this processed and analyzed. So what is the context for this lecture? So last lecture we covered proposals for topics for the first project. Some of these proposals, as they involve real problems, involve real data. So, and that aspect might have been a little bit daunting. So the purpose of this lecture is to illustrate how you can go about this. It's also the goal is to get to data frames, but the goal of the lecture is also to show how to take a problem and take a first cut at it. So take a bite of the problem, a first attempt to come up with a solution to the question. So the other thing that I hope to accomplish with this lecture is that we had 7 proposals for topics. Now, if none of these 7 proposals would be really to your liking, well, there are 5 exercises in this lecture. If you solve all 5 of them and make a whole story about this, then this would count as a project as well. Okay, so what is our problem? So what is the motivation? So we have a question that comes from an observation that some people would claim that in Chicago the winters are becoming milder. So it's stated as a question. Is this really the case? So there are 3 other questions that we will address. Is there actually data out there to address this question? So it could be that some old person, senior person told you this, that in my time the winters were really, really hard. Okay, we want data. Can we verify this? Was there somewhere a specific year that was would warrant this? Okay, if we have data, how do we acquire data? Where do we get it? How do we represent and store the data? So that's a question that's not trivial. A lot of software often starts with that. Now, getting your data inside your computer is often already if you once you get the data in your computer, the problem is already half solved because you have numbers to work with. So I should also say that there are a lot of interesting questions, but if there is no data, then there cannot be a mathematical solution. So the goal of this course is perhaps not to present solutions, but to translate interesting problems into mathematical problems. So once the problems are formulated as a mathematical one, then we have a mathematical solution, or we actually have a mathematical model, and then we can apply whatever we know from mathematics. Okay, so where do we get the data from? So there is the government agency, the National Oceanic and Atmospheric Administration, and there is this website, so the National Weather Service, that provides lots of data. So mainly forecasts. So you can actually, or it used to be, so I have Python scripts that would actually print out, if once you are connected to the internet, that actually would print out the 5-day forecast. right onto your screen. So you can so we are interested here not in, so this is a data analysis project, but our data set will be very limited, essentially the size of a spreadsheet. But once we can do this for one data set, then it becomes also more a software engineering question. How does this scale out? So we are interested in Chicago. So we will so via the weather service we can get interesting data set there, and it comes from the government, so it's a trusted and reliable source. Here you see the nice interface. So it allows you, so if you typed in Chicago, so you also can, if you're living closer to the airports, you can select Midway or O'Hare. I have just selected the Chicago area. So the time range, so the year range we are interested in is the past 100 years. So year one in our study will be 1922. Year 100 is last year. And we look at the average temperature. So that is what we do. So I got to this website honestly via a Google search, and this might not be the canonical way how to get to the data, because there was a problem and I had to do some hacking. So when you use this interface, it allows you to print to a PDF, and then you can save this to a PDF. Or you can also, what I did, ended up doing copying and pasting. So there, you can also download the URL, but you actually get a formatted HTML table. Again, there is a way to get to this. So there are web scrapers, and you can probably parse the JavaScript formatted data automatically. But that would be a software development project where you would systematically do this for many data sets. In case there is no text file, no plain text file directly available. Okay, so what I did is kind of a hack. So copying pasting, it is not the best solution, but I trust what I did, and it's still much better than really typing in. So for 12 months, for 100 years, you still have 1200 numbers there. So typing this all in is a solution, but that could have been error prone. So the copy and pasting worked very well. Okay, so I mentioned that there could be a potential that this could be a proposal for an 8 project, for an extra project. Well, the related question could be, well, we could ask whether the winters are actually becoming more extreme. So we once had a polar vortex, which I remember. So 1 week where it was very bitterly cold. Now, what are the occurrences of the minima and the maxima? So via the website, you can also download the extremal temperatures recorded for also the past 100 years, or you can go further back, but 100 is a nice number. And we will, you can look at the minimum and the maximum. If you find a better way than I did than copy and pasting, I would be really interested in this. So in this lecture now, we will continue with the average temperatures, but the project proposal and the coming exercises are more to this related question. Instead of becoming milder, do we have more extremes? Okay, we have a text file now. how do we go to numerical data? How do we go to an array? And here is where Julia comes in. In Julia, the default data structure, so Julia is oriented towards scientific computing, the default is an array. And here is where we actually benefit from Julia. There is the limited files package, and I would guess that it is standard built in. It's one part of the standard library, and it will read the text file even as the text file is not comma separated. So there are also separate packages for dealing with comma separated values files. Here, when I copied and pasted, I observed that I got data that was separated by spaces. And you see there are 14 columns. So the first column is the year. The first row is a header. And Julia's very flexible with its typing. If I would now select from this matrix, if I would have left off the first row, the header row, then I would have gotten a floating point, a matrix with floating point numbers. But here the matrix, the array data type, is actually quite flexible. Okay, we have an array. So our problem is in some sense already half solved. Look at the data. 2021, the warmest December, well, it was a warm December. Look for the last 3 years. In the last 3 years, the average temperature in December is already larger than 32, so it's no longer, it's not, I mean, it's not yet freezing. So you could say December is not really winter yet. So look at February. So February 2020 was actually quite okay. It was warmer than January, but if 2021 might be a predictor, we still have some, and from experience, the winter is only over when it's full March. Okay, but then also look at March, the last 3 years. We actually really had a warm March. Okay, so already here, from looking at the raw data, and we have them, if we're very good about this, we have them in a Julia matrix, so we can compute with that. So already you're looking here, we can say something about the trend. But notice that in 1923, December was also kind of warm. So it's not conclusive yet. So, and I also actually do not claim that we solve the original question. We merely try to get a handle on the mathematical modeling that we would need to do to address this question. All right. Statistics. So there is the standard library statistics that gives us the mean and the standard deviation. Let's look at the means of the means. And let's say here is one way to test it. We take the first 50 years. So what I first did, back up, I selected from the header, I verified that the 13th column starts with December. Then from the entire table of the matrix, I omit the header, and I select everything on the 13th column. And then here is what a check you could do. Well, look at the first 50 years and take the average of this, and then look at the last 50 years. And then you see that actually, hey, in the first 50 years, the mean was actually larger than the mean of the last 50 years. So that to say that it's not really a clear-cut answer. And perhaps what the second slice then shows, so I should say that the slicing, if you have used MATLAB, then this is all quite familiar. If you haven't, the column, the 1:50 means that you have a range. As we have used already for loops as well. We use the same syntax. But the last two calculations suggest that it might be more relevant to look at decades. So you look at the first 10 years in our data range, so starting from 1922 to 1931, the first 10 years there, the Decembers were a little bit cooler than they were in the last 10 years. So from that, you could say that, hey, there might be an indication that indeed the hypothesis could hold. All right. So working with decades. So in some sense, this lecture is also oriented for you to get somehow encouragement. I hope that the question, especially in this time of year, that this question also is interesting to you, that you kind of get your fingers starting to itch, that you want to do some computation as well. So I will post also the text file, so you could work on the text file. So the exercise 2 can be answered without having to download anything other, going to some other website other than the course website. Now, solving the original or continuing exercise 1, going to the next proposal project. Here, now look at the minima and the maxima for the last 10 decades. Do this, chop this up in bins, and then compare also the standard deviations. So there is the statistics standard library, standard package with Julia that comes with any Julia distribution that will also allow you for any vector to compute a standard deviation. So in the alternative question, are the winters in Chicago becoming more extreme? So that's actually the question that, so the data analysis in exercise 3 is asking towards that. So deviations are here important. It could be that there is no trend in the means, or not really a very decisive trend, but it could be that the deviations are actually more pronounced. All right, pictures. So pictures often reveal something that you don't see by looking at the data, looking at numbers. Here is the plot, and there is a Jupyter notebook that is posted, and you're strongly encouraged to look at this. This contains the one-line instruction. I was originally thinking of putting it on the slide as well, but the plot actually is most important. And the plot actually, I mean, perhaps you see different things, but I see the valleys. So I look at what are actually the coldest Decembers. And so it's also important. I did not change the horizontal axis. So our data goes from year 1 to year 100. So there you are around 60 with the valley, it's actually a spike downwards. You are getting there in the 80s, and we will see this. So in the 80s, the winters were actually quite cold. So depending if you talk to people in my age bracket in Chicago, I wasn't in Chicago back then, but it could be that people who are senior, they will indeed confirm that there were some tough December months. Now this is only December, and again, December is not winter yet, or it's the beginning of the winter. But looking here, and that will actually be the towards the original question. Notice the spike upward. So if we are interested in the warmest temperatures, note that we have the spike. So the spike here for 1923. So 1923 was a warm December, but you see that we almost matched it, and it will become clear in which year precisely, but it was matched in the last decade. So, and you can kind of see that there were still valleys, but they were actually trending upwards. So, in some sense, if you would look decade by decade, you would actually see. But if you look to the global picture, I mean, if I'm looking at this, perhaps you see something else, but you kind of see that there would be, until the 80s and the 90s even, there was a downward trend in the temperatures. But let's not run ahead here. We have a plot. So in data analysis, this is now 2/3 of the answer. Okay. So here is how cold it really was. So I have the Jupyter notebook, but I also had I'm still a terminal person. I like to use the command prompt. So if you take a slice, so on the plot it shows 60, so it's not in the 60s. It's important that we start at 1922. That was our first year that we looked at it. So if we look from 1982, then you can see that 14 degrees for December mean. So I mean, I didn't look at the data for the minima and the maxima, but it could have been that there were some very, very harsh cold days there. So if the average was so far below 32 degrees, then actually what would have been the minimum. And you see that the 80s were pretty cold. So the other year, 31 is good, but 17 is not good either. And then you had another 17 that is repeated there. So we definitely had a very cold decade in Chicago in the 80s. Okay, so this is a plot that looks at 4 columns. So the 4 winter months. And at first it looks like it looks kind of all over the place. But now look at the spikes as well. So the mean in March turned out to be, and that peak here is actually absolute. So the March peak is actually here quite high. So again, what happened there? What was then the maximum temperature in March? So it could also. So here is the other question that you can ask: are the winters getting shorter? So it could be that Decembers are getting milder, warmer, and also the month March is getting warmer. So it could be that springtime is starting to happen sooner. Okay, and these are just 4 instructions. So the Jupyter notebook, it's once you have the data in there, you have 4 instructions. The order in which is, so again, red is January, and you see that January, the mean in the 80s, was actually so the mean that it actually hit 10 degrees. So January, so the related question also, which is now the coldest month in the winter? Looking at the red line here, the red line seems to be the bottom. So is it colder in January or in February? So that's a related statistical question or data question that you can answer. Or you can look at the picture like this. Okay, here is the exercise now for the proposal for an alternative project, or I can ask this once there is a next homework collection. So even if you are interested in this but want to do another project, great, then do these exercises or do one exercise. Here actually the plot between the difference in the minimum and the maximum could be very interesting. So that could be one line that could go up for every month. So if the question whether the weather is getting more extreme, if we have sometimes winters that are much colder, winters that are much warmer, then actually that trend will show in the second part of this exercise here. Okay, we are there almost, which is very good. So the last lecture I went way overboard, so now I deliberately used fewer slides, because in the lecture that happens still, I will have to present on the presentation, and any presentation can be completely ruined if it goes over time. So here I will actually now do the opposite. I will finish sooner. So the original, if you looked into the syllabus and the list of topics, I had data analysis with pandas. We will use still pandas and data frames later in this course, but this is not a software course. So we will use software whenever we feel the need to it. And I will hope now to make the motivation why to use data frames. So in a short, no, in a nutshell, what are data frames? They are spreadsheets for programmers. So all the data analysis can be happening with a spreadsheet as well. So, but we are programmers, and we can use data structures that are very similar to spreadsheets and databases. So here is the definition. So where does the name pandas come from? It's derived from panel data. So you can think of data structures that are one-dimensional. They are called a series. And the word series here, I hope to explain this in next week. So next week we will look at the engineering way of looking at signals and how data is entering as a series. So the one-dimensional arrays, and also if you looked into a little bit in the documentation in Julia, the word series also comes up a lot. That's to indicate one-dimensional sequentially ordered data. And the series is often like we have here, one column, all the average temperatures in December. So the data frame here is the data frame for, so then actually we have the two-dimensional table where we have it over all the months in the year. And we have it for 100 a year. So we have 100 rows and 12 columns. The aspect why do we actually need a data frame? So we are mathematicians, we know matrices, but the nice thing about working with data frames is that we have columns that we can actually label our columns 1, 2, 3, etc. And if we deal with the months, it's perfectly fine. But we can also get access to the columns by their actual meaning. So as I hope to explain in the next experiment. So there is the package pandas.jl. So there is the Python interface from Julia. So Julia is so great, the ecosystem, is that if you were using a very popular Python package before, then chances are very high that you get also to use it in Julia. But let's, for this course, perhaps focus on Julia. So there is also a data frames package that you can install. And that's the Julia analog to pandas. Okay, why are we doing this? So let me motivate this in the last 5 or 10 minutes in this lecture. So this is a session that starts from scratch. And I will speak a little bit from experience. If you look into the books, sometimes you have to go through 100 pages and leafing through, and you still actually don't know how to get your data into a data frame. So I hope to take that frustration here away from you with that example. So I have my text file. I read it in a new, so I started a new. I'm doing using data frames. If this is the first time that you are doing this, then you are installing it. So you have to type yes to get it installed. We can construct a data frame from an entire matrix. Then you have to add auto to it automatically. But actually what you then get looks like a matrix that's kind of decorated. It has an extra column with the row indices to this, and it has an extra header file to it. And actually we are not interested in our entire data set. What we can actually do, we can build a data frame column by column. And that's what we're doing. So I'm making an empty data frame. I select the first column, which contains all the years. And then I have the column with all the temperatures, the averages, the mean temperatures for the month December. So for the 100 years that we are looking at. So in a way, so getting started with data frames, it doesn't have to be frustrating. So you don't need to go through the entire elementary examples that are not relevant for our question here. No, immediately we have our data in there. But yeah, we had it already in a matrix. But here is now why you may want to do this. So sorting. Sorting, if you took a data structures course or any other programming course, sorting algorithms are extremely important. And sorting is built in. So the virtue of using a data frame, that you can sort your data frame to answer the question, what are the coolest or what are the warmest Decembers? I mean, December and warm is probably not really something that you have to use together, but I'm using here warmest opposite to coolest. The mildest December might be more appropriate. Now you see that I edited a little bit, so if you run this you will going to see more, but it's interesting. So I have 10 years, and since I sorted, so the sorting, I'm sorting on the December. But the neat thing is, and if you are using a spreadsheet, have ever used a spreadsheet, you can also do that. But the nice thing here is that by default, also the corresponding year gets sorted, which is very good. So I hinted at the very cool 80s in Chicago. So look at in the 5 coolest Decembers. So 1983 is indeed sticking out there, but then you have 1985 and you have 1989. So out of the three out of 5 of the 5 coolest, so we have 3 of the 5 are in the 80s. So I hope that the first week got you acquainted with thinking about probabilities. If, for example, there was a uniform distribution, then the likelihood that you would expect that every year would have about 50% chance of showing up. So I'm looking at the 5 years, 5 out of 100. But here I have 3 years, 380s that are showing up. So it's kind of an indication that indeed the 80s were cold. Now look at the warmest Decembers. Well, we notice we have 1923, that was that peak there that we observed. That's indeed the record still. But then the second warmest December was in 2015. And then we have another one. The last year actually was also a very warm December. So the last decade has also 50% chance of showing up. So, but you see that the 1980s do not show up here. So the 20s show up. So the 40s are not represented, the 50s. So we have twice the last decade that shows up. So that's another indication that indeed the winters, and this is again only the sample in December. So you could also say that we have to consider all the data. We have to consider also January, February, and March. And that's what I leave off as an exercise. Actually, I haven't formulated this as an exercise as for the means, but if you want to be more thorough in the explanations, then in your study, you have to consider all the winter months. But that's more the repetitiveness. And this is where also the programming part might play in. Instead of doing this, well, it's still not really word the loop because you have only 4 months. But suppose that you can extend this study. That the other study would be people say that the cities are getting hotter opposed to the countryside. So you can take very remote villages and or places where they have also temperature measurements and compare against Chicago as well. So again, if many of you would be interested in the project, you can also ask different questions. Is the countryside spared? Are the winters on the countryside harder? So that's the other question that you could ask. You could have somebody who grew up at the countryside and their winters are harder. Is that true or not? Let's examine this. Okay, so the purpose of this lecture was not to present an entire study, and in some sense, if this is your project presentation, you will have only 20 minutes, not as I'm doing almost 40 minutes. But I've hoped that I also have motivated the use of data frames. Okay, I will end with some recommended sources. So first of all, if we are doing a data analysis, then the first computations are looking at means, standard deviations, plotting, and sorting. So later in the course, we will still have a course on regression. If you took numerical analysis, or if linear algebra is still fresh, then at some point you might have been jumping up and down and saying, hey, why don't you show us how to do least square fitting? And yes, indeed. So that actually goes towards the mathematical formulation of the question. So formulate this as a regression problem. But we will later in this course see some things. But if you are good at linear algebra, then by all means, and if you do this project here, do a linear least square fit and look at the slope of the data, if it's really going up decade after decade. Okay, so I had planned not to spend more than 40 minutes on this lecture, so I'm getting close to this. Two sources are recommended. So there is the Pandas book, and then there is the second reference, which is a free book, free available to download. It also makes the case for Julia. if in this course this is your first encounter with Julia, then this book here makes the case for Julia. I hope that coming from either MATLAB or Python, that Julia is not too much of a culture shock. It's a free book, so there is, you may know from software, there are free and open source licenses. The book is licensed under the Creative Commons, so that also guarantees that it will somehow remain free in its form. It's certainly not a perfect book. No books are perfect, but it is for now, for data science, it's a very good source. Okay, I'm in 40 minutes. I stop here.